I will, all 45 of them.
45?
45.
That's a lot. That's enough power to move it off.
All right. It's the 10th, which means we're getting close. All right. You will recall, hopefully from Hess's Law, that we can reverse a reaction. And if we did that, we would reverse the sign. Or we could double a reaction or half a reaction, whatever we feel like we need to do to get it to work. And whatever we would do there, we would also do to the enthalpy. Does that sound familiar? Okay, let's attack another practice problem then. So carbon occurs in two forms, graphite and diamond. The enthalpy of the combustion of graphite is negative 393.5 kilojoules per mole, and half of the, and that for diamond is that. Calculate delta H for the conversion of graphite to a diamond. So we have those two equations at the start. Find delta H for the third one. Will you go ahead and attack that for me? Cal, thumbs up if you can hear me. Okay, perfect. I thought we'd have a couple more. Apparently not. Raise your hands when you have an answer. 1, 2, 3. Okay, you can put them back down. I don't want you to wear out while we wait. Okay, anyone else have an answer now? All right, I'm going to go on. This should be about a 30-second question. So, before I answer it, the amount of quarantines is creeping up pretty quick. So let's review what to do if you get quarantined, are sick, or just plain out don't feel like coming to class. All right. If I get a notice, you'll get an email. Okay, so 2 kids in here are officially quarantined till the 18th. That's rough. They'll miss my birthday. So they get a big long email. It's right here. So everyone will get this standard email if they do whatever. I just change your name right there. You with me? In bold, the best thing you should do is attend Zoom. There's that and the password. Then it also tells you, like, go to the daily guide. But let's say you just want to be gone for 3 days, but I don't know. So anytime you miss on Canvas, you can go to AP Chemistry 2020. The daily plan is listed right here. We are in November. October's still published because there's people that still haven't done October stuff. And I know they won't, but whatever. It's still there in case they decide they want to. All right, so you would click on the November daily plan. It would tell you what we're doing each day. At the end of the day, I've started putting the videos here and the other place. They're there twice, but whatever. So today we'll be doing Hess's Law problems and learning about heats of fusion. By the end of today, there will be a video clip there that you could watch. So that's the daily plan. You can also, there are resources for each chapter. The Zoom link, if you need it, would be right here. It says welcome and Zoom link in caps, Zoom info right there. We're on thermal chemistry. So these are all the links to the textbook that you could read online. Here's the assignment that's locked now. Here's some additional resources. All right, so that's the PowerPoint. This is an endo and exo quiz I haven't had you do. And that's that. So you can get pretty much all the resources you need right there on Canvas. Check the daily plan. Join the Zoom. even if I get quarantined, I plan to teach you on Zoom live from my room. All right. Yeah, I'll be right there. You'll have a sub. Each hour, one of you will log in on my computer, go to your Canvas class, click on that Zoom, and you'll join with me at my house. And it would just be right there. It is funny. But okay, I have that camera right there that's not ever on. But if I'm zoomed, if I'm quarantined, that will be the main camera, and it can see everybody except for these two desks. So you could raise your hand. The audio will be tricky because it will be that microphone. So I'd hear these pretty good. Like, yeah, you could. Okay, so anyway, yeah, you can grab an iPad and join and chat. You can do whatever you want. We'll get the job done. If we shut down, which we're close, I think everyone knows that. I'm not a doomsdayer. I'm just going to run it right out of here. The daily plan will be there. I will Zoom the same time, just like it's a real class. If you can attend, great. If you can't, watch the video. Easy enough. There'll be shorter things, like not every day do I need a video. There's plenty of online AP chemistry resources, but whatever. That's the plan if you get stuck. Okay, let's come back here. Wow, where are the other kids? All right, so Hess's law, we need to take these two reactions and put the graphite on the left and the diamond on the right. So I look at number one and it has graphite on the left and it has the same coefficient. So I don't need to change the top number at all. Then I need diamond on the right. The diamond is on the left here. So I have to switch this reaction. I don't know why I did that. In order to get diamond over here, I have to reverse the reaction, which means what do I do to this number? I change it to a positive. And then I add these two numbers and I get just like 1.9. Okay, good question. The O2 absolutely does matter, but if I write this backwards now, it would be CO2 right here. I'm just writing it this way, goes to O2 plus C diamond. And you'll notice that, let me get rid of this so it's not confusing anymore. You'll notice I have one O2 on the right side now and one O2 on the left. So since they're on both sides the exact same, they would cancel out. You don't ever, like, I don't require you to cancel them, but that's how you check to make sure you've done it right. Then it wouldn't have worked because there's no O2 in the resultant. So it would have had to have canceled out. Yeah.
Are you gonna have it where like the C graphite and the C diamond are gonna have different like coefficients or anything else like that?
Yeah, I could. We're gonna do plenty more problems with all of those contingencies. We'll see. Right. Judah.
So because you switched it from the positive now, you just subtracted to subjective.
No, I made this a positive and then I add them. I add them just like I'm in third grade. So I put a plus sign right here, negative 395 plus positive 395. No, that's the delta H to make graphite become diamond. Now, you're like, what? It really only takes 1.9? Why are there not diamonds everywhere? Nope, that's a really small amount of energy. But the thing we don't know about this is the rate.
Yeah, doesn't it take like forever?
Takes an extremely long time. So the energy change is almost nothing, but the rate, which we learn about in chapter 14, the rate law is why this is a problem. not the energy.
What about artificial diamonds? How does that work?
They do things to increase the rate. That's literally all they're doing. Pressure and heat. They do it in an autoclave. Okay. Here's another problem. Calculate delta H for this reaction using these reactions. Take a couple minutes and try that one. Okay, so the 5/2 does seem confusing. And I foreshadowed this a long time ago. These things are written per 1 mole of this.
Oh, so
But
what we gotta do is
But this stuff to balance is really 2, 5, 4, 2. So to make it per 1 mole, they just divide everything in half. And this became a 1, this became a 5/2, this became a 2, and this became a 1. So yeah, I need this as a product, so absolutely I would rotate it over. Okay, keep going on your own. All right, raise your hands if you have an answer. Nobody? I have 12 blue sheets so far out of 19 kids. That's about average. 13 out of 19, that's a good sign.
mine's almost done. I just need to bring it in.
Okay.
Done by today.
Oh, yeah.
Yeah, you were on your knees begging and promised it would be done by today.
No, it will be done by today.
Okay. About the time I get my shed. I bought a shed the first week of August.
Oh, really?
It's supposed to come tomorrow. So help me if it doesn't show up. All right, raise your hands if you have an answer. John Nation, only one? Or you're raising your hand. 2, 4, 5. Wow. Okay, one more time. Who has an answer? Raise your hand high. Those of you that don't have an answer, go talk to someone that does and figure out what is going on. I'll pause this. All right, so here we go. Cooper Lloyd said, so Davidson, these aren't really as scary as they look. In my opinion, these are very simple. Okay, here is it all written out. 226.8, who had the right answer? Did anyone have the wrong answer? Okay, so this is why. If you'll look, ethylene, no, what's that called? Acetylene is what this is called. In this, it's on the left. Over here, it's on the right. Same coefficient, so I better make this a plus sign, correct? I don't need to multiply, don't need to divide. I'm all good there. All right, carbon, it is correctly written, but needs to be doubled. So it's 2 of all this to get that to work. So I'm going to double this. No, there is a section of the test that is one of these. All right, H2 is on the left. It is on the left. It has a 1. This has a 1. So there's nothing to change here, correct? All right, so now I just do my addition. So 1299 plus negative around 800 plus negative 285, we end up with 226.8 kilojoules. Now, if you will look, it has to balance out. The water, because there's no water up here, right? So the water better cancel out. There's a water, just a 1 here. There's a 1 here. So the water cancels out. The other thing that's not up here is oxygen. And that seems a little tricky because we have fractions. There's 5 halves here, and there's 2 and 1/2 here. Well, what is 2 1/2? That's 5 halves. So this cancels out, and all of these cancel out. And now I'm left with what I'm looking for. All right, oh, CO2, sorry. There's 2 CO2s here, 2 CO2s here. Now I'm left with what I'm looking for. No, opposite sides. Yep, if they're on the same side, they're additive. Opposite sides, they cancel. Okay, one more.
Yes. Yes, please.
What about the one yesterday? Oh, he's talking about enthalpy or calorimetry problems, I'm sure. Okay, give this a shot. What am I doing? I meant to pause. Come on. All right, I look up here and I have NO on the left. Do I have NO on the left? Yes. Do I need to change the coefficient? No. So this one just stays as written. I look up here and I have just singular O on the left, but here it's on the right, correct?
Yeah, you need to flip it.
All right, so I need to flip it and do what?
Divide it in half.
All right, divide it in half, correct? So this becomes a negative and I get half of it. It's a negative because I had to reverse the reaction and I need to divide this by 2. Are we okay with that?
Oh, so you divide by 2 on each side. Okay.
Right. Now, what that does, it throws some things off. Like, why does this part even exist?
Yeah. But don't you need to flip it
It's-
to make it cancel out?
I have to make things cancel out. So see how this one was this, I did not edit the first one, but it has O3 over here. Is O3 up here at all? No, so I have to flip this one so that O3 will cancel out. Do I need to change any coefficients?
No.
I do not.
Oh, so O3 will cancel.
Oh my gosh, wait, did I actually do this right?
Mhm.
Hold on, wait a minute.
It also makes the O2 cancel out.
Okay, so that's what's kind of confusing. You're not realizing, you know, you can just cancel them out like that.
Yep, because look, you'll have one O2 here, and then you'll have a half O2, which is 3 halves of O2. And remember, this will be on the other side, and that will be on the other side.
So that will cancel out.
They'll all cancel out.
Plus the O3.
Okay, so I need to do all this math. It's tricky.
It's negative 304.1.
Negative 304, we'll find out. Boom.
Shoot. Thank you for coming. That's how I
All right, who had negative 301? Okay, that one's hard. This is as hard as it gets.
I think it's
Mhm. Okay. You just have to be real careful. If there's a piece that looks like it's unnecessary, it is necessary because it's an intermediate step. We'll learn about that. It's an intermediate that helps the reaction happen but doesn't show up in the reaction. Okay, let's call this our last one. Oh, we already did this one. Yeah, we did. Okay, we have not done this one, right? Here we are. So I like to look up here and just work my way from left to right. I generally don't worry about oxygen because it always pretty much takes care of itself. So I'm going to look at CS2, liquid. I need it on the left, but here it's on the right. So what do I need to do here? All right, I need to flip it, so I make that a negative, correct? All right, then I'm going to skip that. I'm going to come to CO2. I need CO2 on the right. It's already on the right. The reason I skip oxygen is because it's in more than 2 places. So fix the things that are in one place first, and usually the 2-place ones fix themselves. Okay, do I need to put a coefficient in front of CO2? No, I do not. All right, next, I come to SO2 gas on the right. Sorry, thank you. 2 SO2 gas on the right. Do I have SO2 on the right? Yes. Is it a 2? No. So what do I need to do here? I need to multiply everything by 2. So I'm going to put a 2 here, a 2 here, a 2 here, and then I multiply that by 2. And then I'm ready to roll math-wise, right? So Cooper, how did I get 3 O2s? I had 1 of them plus 2 of them, and that's how I get 3.
So I think on these problems, you want to look at the right side of what they, like, you want to look at that first. Like you want to look at the CO2, the SO2, the CS2 first, right? Is that what you would recommend? Like I was looking at the O2, I was looking at the left side.
I start from left to right. I started with CS2 to double check where it was. And then I skip oxygen because I see it in 2 places. Then I went to CO2. Then I went to SO2. A lot of kids will start here and they'll check, all right, does this match up there? And they flip. It doesn't matter the order you go in. No. Okay, what did this all add up to? All right, who had it right?
I did Davidson.
Kel, how'd you do?
I'm so proud of myself. I did it. Good job, Gabe. Thank you.
Thumbs up, Kel, or thumbs? Oh, I was close. Okay, I got you.
I was trying his best.
All right, he's doing fine. All right, these are on the exam. Well, there's one of them. There's probably more, but I'm not going to. I don't know. Do you feel all right with them? Do you want one more? Are we good?
What is this called again, Davidson?
One more.
This is called Hess's Law. That's supposed to be an apostrophe right there. Hess's Law problems. Okay, last one then, right here. Last one. Try this one.
Yes.
Hess's. There are, I don't know. In my book, it's written with an apostrophe S.
It really is.
Uh-huh. Because it's only one person. Okay, keep going. We got this.
I got this one. You did super, I believe. Thank you so much.
That sounded passive aggressive, didn't it?
Yeah. I don't know what I did, Gabe.
That's on me. Sorry, I wasn't trying to be mean. I was actually thank you so much, baby.
Just got even worse. It's going downhill.
I'm on this side of the room because I don't want to sit next to
Cooper's,
like you passive
he's
aggressive,
mad
but
because of
baby,
basketball.
You're so dumb.
Yeah, it actually stinks. I can't believe it.
All right, who has an answer?
Almost.
Okay, sorry. Well, I figured if Cooper Lloyd had it, everyone had it. I'm just teasing.
If I have it, I believe in every one of it.
What? Here we go.
You're gonna forget what I said.
All right. SiH4 is on the left. Is it on the left here? No. So I need to reverse this,
No.
right? Do I need to change the coefficient? No. So I reverse the sign. That one looks good. I'm not going to worry about O2. I'm going to come over to SiO2. It is on the right. Is this on the right? Yes. Do I need to change its coefficient? No, I do not. So this is one that's just going to be normal. Okay, then I come to water. There are two waters on the right. Up here, there's only water on the right, but it's only one of them, right? So I need to double this whole thing. So two of these, I'm going to say this is just a one because I'm doubling a half. Two of these, are we okay with that? And then I must also then double that. And what do I get? 14 something, or is that?
Yeah, 1429.
1429 kilojoules.
Negative.
Okay, negative, thank you. So if
There.
this was a test question, it'd say, is it endo or exothermic? And you would say exo. You could, this could be on a test and it could say, all right, how much would this raise 50 milliliters of water? Go ahead.
Since it changed, that half oxygen changed to one, that's where we get two oxygen from.
Yep, we had the one plus the one.
Do we just have an extra two hydrogen floating around?
No, because they're right here, and then this one was flipped.
So that's a.
So yeah, it would have been over here, so it would have canceled out. There's two of them, and this one would have canceled out. Yep.
Okay, wait. I'm gonna answer that.
Okay.
Actually, well, I actually don't want to say it. 'Cause I don't care. Wait.
What were you gonna put?
Well, so is that the one where you have to like change it like 4.184 and like identify like the grams plus the
Yeah, you would solve for Q equals SM delta T. You would solve for delta T with 1429000 joules. Because this is 4.184 joules.
What's M?
M, it said 50 milliliters. It would, and I said water. It'd have to say of solution. It'd be the mass. So, I mean, we don't have to do it, but since you seem to care, let's say the solution is 50 grams. So we're solving for delta T, right?
Yeah.
So delta T equals Q over S M.
And Q would be our kilojoules.
Yep. Our joules.
Yeah, well, our joules, yeah.
What was the question you asked? Did you do this?
I just said on the test, it could also say how high would that raise
In the equation, would you
50 milliliters of water? What's that?
If you had a negative on Q, would you keep it as a negative?
I would not personally.
Don't you have to have like isn't that a negative 4.184 though?
Yeah, like
Oh, but if you
it just cancels out. Yeah, it's going to make it really hot.
Yeah. 0.7834.
So, lot.
A lot. Can I write down the test, Davidson?
You can get it wrong.
Aw.
Okay, that, my friends, is Hess's law. I hope that you're okay with Hess's law. Next, enthalpies of formation. More math.
Yay.
Everybody loves math.
In this class, yes.
All right. So here we are. An enthalpy of formation. Delta HF, that's the formation, is defined as the enthalpy change for the reaction in which a compound is made from its constituent elements in their elemental forms. So if I took H2 plus O2 and made H2O, the delta H for this would be the energy, I think it's like 385 or something like that. It would be the enthalpy change for when water is made from its constituent elements in their elemental form. So I should put a gas, liquid. Okay, these numbers are given in tables. So when you have a problem on this, the problem, it will give you what these enthalpies are. Now, here's a question. If enthalpies of formation measure the enthalpy change when a compound is made from elements, what do you think the enthalpy change is when an element is formed?
If it's not formation, wouldn't it be, what's the opposite of formation? Like, it's the deformation, non-formation,
I don't know.
information?
The answer is 0. We don't make elements. They were created in stars that then exploded.
Let's make a star and explode it.
It'd be cool,
Let's
but
watch it.
we already have those. Okay, so you won't find H2 and O2 in a table because they just figure you'll know that they're 0 because they're elements. But you could find water. It would just say H2O, and then the table would say, and I could be wrong, don't quote me on the 385, but it would just have 385. And what that would mean is this. All of this stuff gave off that much energy. Okay? The standard enthalpy of formation is a measure of the energy released or consumed when 1 mole of a substance is created under standard conditions from its pure elements. The symbol of the standard of enthalpy of formation is delta H naught, and the F should be lowercase. Deltas change. This little naught or degree signifies that it's standard. What we mean by that, it means room temp and room pressure. Just how nature would do it. Okay? We're not putting it in an oven. We're not putting it under pressure. That's what it means if you ever see a naught sign. F, it indicates that the substance is formed from its elements. Okay. This is what we're going to use a lot for the next 2 days. And they're not bad. You just have to be careful. The equation for the standard enthalpy change of formation, originating from enthalpy being a state function, shown below, is commonly used. All right, so this is kind of cool. If we can look these up in a table, what the things are that are in a reaction, we can find the overall change in the reaction by using the sum of the delta F naught for the products minus the sum of the delta F naught for the reactants. This in math means the sum. Sum means you add up all the parts. And it's always the products minus the reactants. It's a good day when I've made your finger hurt from taking notes. You're welcome. I just need 5 more minutes, but I don't have them. Yep, that country song. Okay, this is how one of these would look. Oh, let me go here. We'll come back to it because we have to. You would be given a balanced reaction. You would be given a table. So this would be the table right here that shows you the enthalpy change for the parts of the reaction. Then you just plug them in with their coefficients. So see how there's a 2 right here? There's only one of the, or sorry, one product. So I would say 2 of NO2, 33, minus 2 of the NO, plus it's going to be 0, right? It's 1 times 0
Sorry, why did you put 33 and 90?
right here.
Oh,
And then I just plug them in. Now, like I said, I wish I had 5 more minutes because that might have just confused you. But it's super, it's the same thing I've always said. If you're a good accountant, you can knock these problems out of the park. You just got to be careful with signs and making sure you do the order of operations correctly. And we'll do a bunch of practice on these tomorrow. Your test, this is the last thing on the test. Your test is 2 days away. It's Thursday. Okay. You guys are great.
yeah, are you gonna be here for school, Davidson?